So hello students. So let's move. So here we are there with motion in a plane. Move on. So let's discuss the questions which were there in the set A of your exam. As we discuss these questions, I'll try to explain the theory behind a few of those questions at least. Now the first question, when two vectors of magnitudes A and B respectively are added, the magnitude of the resultant vector is always So this is, understand one thing, when scalars are added, A plus B will always be equal to A plus B. But in case of vectors, A vector plus B vector could be equal to A plus B, it could be less than A plus B, but it can never be more than A plus B. Okay, so that is the magnitude of that. So magnitude of A plus B is less than equal to mod A plus mod B. It can never be more than mod A plus mod B. Okay, so based on that, it can be equal, A can be there, less than A can be there, greater than A plus B, not greater than A plus B. So only thing we can say is when two vectors of magnitude are added, the magnitude of the resultant vector, so I can only say it is not greater than A plus B. Otherwise, none of the others will work out. Two bodies were thrown simultaneously from the same point in a straight line, both with a velocity of 20 degrees. So one is going up at 20 meters per second. So after 1.2 seconds, I already explained, it will be going up at 8 meters per second, and the distance here, the velocity is 20. So this is after 1.2 seconds. So the way I find it out is 20 plus 8 is 28, by 2 is 14. So 14 into 1.2. So 14 into 1.2 will be 14, 16.28, 16.8 meters. So from the base, it is at 16.8 meters high. The other body is sent this way, it will go this way. So when it goes this way, the horizontal distance of that particle, so the velocity is 20 meters per second inclined at 30 degrees, right? So this will become the cos theta. So 20 into, so that is 10 into root 3. So 10 into root 3 will be 17.3, let's say, meters per second, and the upward velocity will be 10 meters per second, right? So what will happen is after 1.2 seconds, it has already gone to its peak height, and then it has come down by 2 meters. So from the ground, it is 8 meters, and in the horizontal distance is 17.3 into 1.2 meters. 1.2 meters from the starting point. So if I look at this, 17.3 into 1 is 17.3, 17.3 into 2 is 3.6. So I'll add just 3.6 here. So this is approximately 21 meters. So now what can I infer? So the first particle, suppose this is the origin, the first particle is 16.8 meters high, 16.8 meters high here. The second particle, the horizontal distance is 21 meters. So this is 21 meters, this is 21 meters, and from here to here is 8 meters. So this distance will become 8.8 meters, and this distance is 21 meters. So when I find out the square and then add them, so 21 squared is close to 441, plus 64 will be like 500. So the distance is less than 25. Had it been 625, it would have been less than 25. So 20 can't be the answer. So 24 seems to be the best choice. So I'll go for 24. The minimum number of forces required to keep in a plane that can keep a particle in equilibrium. So equilibrium means what? Equilibrium means sum of all forces is equal to 0. Okay. So now if there is a body here and there is a force like this, there is a force like this, there is a force like this, then this body can be in equilibrium. With two forces also it can be in equilibrium only if those two forces are equal forces acting in opposite directions. So the question is, the minimum number of forces of equal magnitude in a plane that can keep a particle in equilibrium. It seems like it is 2, but that is so it's a tricky one because they are asking you for minimum. Even 3 can keep it in equilibrium, and there also there are conditions. So here the condition is there should be 180. So I'll go for option B, but otherwise remember students, if you have one charge here, one charge here, for this charge to be in equilibrium, it can never be in equilibrium even if there are two equal forces. So only if there are two collinear forces that can be in equilibrium. Otherwise there has to be a minimum of 3 forces to make a body in equilibrium. I am tempted to go for 3, but because they have already told me that they are equal magnitude in a plane, so these two are also in a plane, so I will say option B and I will not go for C. If C is the answer, don't worry about it, you know it, but still you made a mistake. It's possible. A train is moving due east. There's a train moving due east, and a car is moving due north with equal speeds. A passenger in the train, so there's a passenger here in the train. This is the the train and this is the car. So we are talking about the velocity of the car with respect to the train is Vc minus Vt. Velocity of the car with respect to the train is Vc minus Vt. So I will say it is equal to mod of this, and it will be j cap minus I cap. So j cap means it is north, minus I cap means it is west. So I will say the answer is northwest. These kind of questions come quite a bit in the NEET exam. I don't want to make a mistake because it's a easy question. So if I draw my diagram correctly, there is no way I will make a mistake. A particle P moves with the speed along A, B and BC sides of a square. So there is a square here A, B, C, D, and the particle moves this way. Another particle Q also starts at A and moves with the same speed but along AD and DC. Okay, then the respective changes in velocities are equal in magnitude but different in direction. Change in velocity is V final minus V initial. So V final is along the along I cap. V initial was along j cap. So the change in velocities are different, equal in magnitude but different in direction. Different in magnitude, no. Different both in magnitude, no. Same both in magnitude and direction, no. So I'll go for option A. Equal in magnitude but different in direction. Well, so for the first person, okay, we have to be a little careful about it. They're talking about the change in velocity. Say change in velocity is delta V. Delta V is V initial minus V final. So the first particle is moving along. Along j cap. The second particle is moving along I cap. So I don't think they're. So I'll go for equal in magnitude but different in direction. A river is flowing from west to east. So there is a river which is flowing from west towards the east with a speed of 5 meters per second. A man on the south bank, so this is the south bank of the river, capable of swimming at 10 meters per second in still water, wants to swim across the shortest time. So the shortest time in which he can cross it will be when he goes at an angle. So the direction in which he should swim, he should try to swim in this direction, but he'll be he'll be adrift in this direction. This is 10, this is 5. So if this angle is theta, tan theta is equal to 1 upon 2. So theta is equal to tan inverse of 1 by 2. So he should be going due north. So he should swim due north. Because of the stream, he'll be moved apart. A hunter aims his gun and fires a bullet directly at a monkey on a tree. So there is a monkey here and he takes the gun and then he shoots. At the instant the bullet leaves the gun, the monkey drops. So the monkey falls down. So he is coming down with an acceleration due to gravity g. Remember, as the bullet is going this way, so the bullet also goes with the same downward acceleration g. So the bullet will hit the monkey. So it will hit the monkey irrespective of its weight. Keeping the speed of projection constant, the angle of projection is increased from theta to 90. Then the horizontal range of the projectile. So this is the horizontal range of the projectile. Some of you may have forgotten the formula for that. Remember, upward velocity is u sine theta, horizontal velocity is u cos theta. Always in projectile motion, time of flight is the most important thing. So the time of flight is 2 times u sine theta over g. So from there I can say the range is equal to u squared sine 2 theta over g. So when the range is u squared sine 2 theta over g, up to 45 degrees the range increases and then decreases. So increases up to 45 and decreases after that. So we will go for this option. A heavy particle is projected up with a velocity at an angle with the horizontal to into a uniform gravitational field. The slope of the trajectory of the particle. So now they have projected a particle. So the particle goes this way. As far as the slope is concerned, tan theta is the slope. So you see the slope first increases and then the slope becomes negative. So the slope decreases and then becomes negative. So option A will be the right one. Again, remember, when you draw diagrams and work, things become very simple than when you just keep reading the question and start thinking. A stone is just dropped from the window of a train moving along a horizontal track. So the train was moving this way and then a stone is dropped. So when the stone is dropped, it would move this way. The path of the stone is a parabola if you look at it from here. But if you look at it from the train, it will just be vertically downwards. A parabola for an observer standing by the side of the track A is true. A horizontal straight line for an observer inside the train. No, it's not a horizontal straight line. It's going to be a vertical straight line. 1 is true, but 2 is false. So I'll go for option 2. That is option D. 1 is true and 2 is false. A bomb is dropped from an aeroplane flying horizontally with a uniform speed. The path of the bomb. So this is the plane going with the uniform speed, and if a bomb is dropped, because of the horizontal velocity, it will again take a parabolic path. A parabola for the pilot of the aeroplane is wrong. A vertical straight line for the pilot is the correct one. So option C is the correct one. Both these questions are similar questions. It will help. Now to calculate the range, again calculate the time of flight. Velocity of the plane into flight will give you the range. Okay. Remember, in all kinds of projectile motion, time of flight is the most important. A particle is projected at an angle 60 degrees with a speed 10 root 3 meters from a point as shown in the figure. At the same time, the wedge is made to move with a speed of 10 root 3 meters towards the right as shown in the figure. Then the time after which the particle will strike with the wedge is how much? Okay, it's a interesting question. So what is going to happen is, so there is a wedge here and the particle is thrown this way. Now the wedge is moved this way, so after some time the wedge may come here and then the particle may hit. This angle here is 30 degrees and it is projected at 60 degrees. So if it is projected at 60 degrees, something tells me that it will not hit, but let us see what will be the condition. So if the particle is moved at 60 degrees, okay. So for them to meet, the horizontal distances must be the same. So 10 root 3 means the horizontal velocity is 10 root 3 into cos theta. Cos theta is 1 by 2, right? So 10 root 3 into t must be equal to 10 root 3 into 1 by 2 into some t. So this guy is moving slow, this guy is moving fast. So obviously they will meet. Obviously they will meet. Now the question is after how much time? So after how much time will now depend upon the angle. So let me see. Projectile is fired from a level ground at an angle above the horizontal. The elevation angle of the highest point as seen from the launch point is related by the relation. So this is the projectile at the topmost point. The highest point will become equal to u squared sine squared theta by 2g. So this is this height and this range is u squared sine 2 theta by 2g, that is half of the range. So this angle theta should be such that tan theta is equal to this by this. So when I say tan theta is equal to this by this, I will see that tan phi is equal to sine squared theta. So it will become sine theta by 2 times cos theta. So that will become 2 times tan theta. So tan phi is equal to 1 by 2 times tan theta. So I'll go for option A. If retardation produced by air resistance of a projectile is 1 by 10th of acceleration due to gravity, the time to reach the maximum height, what would happen to the time to reach the maximum height? If retardation is 1 by 10, that means if instead of 10%, it would now, instead of acceleration due to gravity being 10, it will become 11. So when it is going up, it will become 11. So if it is becoming 11, t is equal to half g, I can say that h is equal to half g t squared. Okay, so from there I can say t is equal to 2 times h over g square root. So if retardation produced by air resistance of a projectile is 1 by 10 of acceleration due to gravity. So now gravity is increasing by 1 by 10, so it has become 1.1. So now what will happen to h? They are talking about the time taken to reach the maximum height. Obviously time taken will reduce because everything depends upon the vertical velocity. Vertical velocity will remain the same. So now it will be time taken will become v sine theta by 11. So because it has become 11, when it goes to the numerator, it will become 0.9. So it will decrease by, so time taken will decrease. Time taken to reach the maximum height will decrease by 9%. Two inclined planes. I hope you are able to understand this. See, the time taken to reach the maximum height depends upon the vertical component, that is u sine theta. U sine theta will remain the same whether there is air resistance or not. Now as far as because the this is increasing, instead of 10 it will become 11. So it will become g into 1.1. Now 1 divided by 1.1 will become equal to 0.9. So it will decrease by 9%. Two inclined planes OA, OB intersect in a horizontal plane having their inclinations alpha and beta, and with alpha and beta with the horizontal. So there are some few unnecessary words. Intersect in a horizontal plane as shown in the figure. So we don't have the figure. This is the figure. A particle is projected from point P with velocity u along the direction perpendicular to the plane OA. The particle strikes plane OB perpendicularly at Q. So the particle is projected, so it goes this way and then again it comes and it strikes. If alpha is equal to 30, the time of flight from P to Q is how much? So there is something to do with the projectile is projected perpendicular. So when the projectile is projected perpendicular, it will go and it will hit here. So if I look at it, initially it had a vertical velocity and a horizontal velocity. Finally, it again has the horizontal velocity and the vertical velocity. So the vertical velocity and the horizontal velocity, this and this are the same. There is no change. And now because it is hitting here, this and this also, these angles are symmetric. So this is equal to this. So this is just like vertical motion and coming down. So they are asking me for the time of flight. So in vertical motion, what is the time of flight? U by G. So now what will be the flight? Now what will be the time of flight? It is projected perpendicular. So if it is projected perpendicular, so the horizontal component, the vertical component will become u sine theta. So this is 30. So this is 30. This is 60. So this is u cos 60, this is u sin 60. U cos 60, this is u sin 60. So it will become 2 times u sin 60 by g. So 2 times u sin 60 by g will give you u by g. I hope you are able to understand. What I am saying is, this is the diagram. It was projected and it goes and hits here perpendicular. So there is a horizontal velocity, vertical velocity, horizontal, vertical velocity. And this is symmetric. These angles are the same. Because these angles are the same, this will happen when the height is the same. If the height is the same, there is no change in the velocity of the body. So it is simply like upward downward motion. So the upward component is u sin theta, time of flight is 2u sin theta by g. So 2u sin theta, sin 60 is 1 by 2. So sorry, I am making a mistake. It is 2 times u sin 60 by g. So this is 30, this is 30, this is 60. So this is u cos 60, this is u sin 60. So sin 60 is root 3 by 2. So 2 cancels, root 3 u by g, root 3 u by g. So this will be the correct answer. So B is the correct answer, not E. A shell fired from the base of a mountain just clears it. If alpha is the angle of projection, then the angular elevation of the summit beta is how much? So we just seen this kind of a question. So this is given as h. So tan beta is equal to h divided by range by 2. So that is equal to 2 times u squared sine squared theta by range. Range is by u squared sine 2 theta. So the 2's will get cancelled, g's will get cancelled, these 2 will get cancelled. So we will get this to be equal to 1 by 2 tan projection alpha. So 1 by 2 tan alpha. So from here I can say tan beta is equal to 1 by 2 tan alpha. We have already seen this. So tan inverse of tan alpha by, so option C, this will be the correct. If P is in equilibrium, then T1 and T2. So here we have a experiment here where there are 3 forces acting on a body and they are telling you that the body is in equilibrium. If the body is in equilibrium, then T1 cos 30 must be equal to T1 sin cos 60. Okay, so T2 cos 60. So they are asking me for T1 by T2. T1 by T2 is cos 60. Cos 60 is 1 by 2. Cos 30 is root 3 by 2. So 2 gets cancelled. So it is 1 by root. What have I done? I have taken the horizontal components of this force now and then this. So this should be equal to this. The horizontal component, this will not have any horizontal component. So because it is in equilibrium, this should be equal to this. So T1 cos 30 must be equal to T2 cos 60. Raindrops are falling downwards vertically at 4 kmph. So raindrops are falling this way. For a person moving forward at 3 kmph. So now this forward or backward we don't know, because for a person this could be forward, this could be forward. So we'll assume any one to be forward. So we'll assume this to be forward. Okay, so they are asking you for velocity of the rain with respect to the man. So that is equal to VR minus VM. So VR minus VM will give you velocity of the rain is 4 j cap minus VM. So minus 3. So the net will become 5. So it is 5 kmph. But this is just a guess that I have made. It can be like this also. When you do it like this, it will be this. But velocity will be the same. But if there are some more questions, it will be difficult for us to find out. A man traveling at 10.8 kmph in a topless car on a rainy day, he holds an umbrella at an angle of 37 degrees with the vertical so that he does not get wet. If the raindrops fall vertically downwards, what is the rain velocity? So again, the man is moving at 10.8 kmph Rain is falling vertically downwards, right? So if the rain is falling vertically downwards, he would keep his umbrella such that velocity of the rain with respect to man. So that will be velocity of rain minus velocity of man. So velocity of rain is how much? Minus, so these kind of questions we will find it little difficult. Minus 10.8 kmph, this is the velocity of the rain, minus velocity of the man. Sorry, this is the velocity of the man. Velocity of the rain is the question. So velocity of the rain minus velocity of the man. And now they have given us that at an angle of 37. So if they were given us at an angle of 37, so I need to know that tan 37 is how much. So tan 37 will be 10.8 divided by tan 37, yeah, because he's keeping it like this. So it will be 10.8 divided by velocity of the rain, velocity of the rain. Now I don't know what is tan 37, so I have to look up to tables and then find out, but otherwise I'll get the answer. Okay, so tan 37, assume tan 37 is sin 37 by cos 37. Cos 30 is root 3 by 2, that is 0.7. So if I go for 0.7, so cos 30 is 0.7. So cos 37 will be less than that. So if it will be less than that, so I'll go for 2 by 3. I'll go for the ratio 2 by 3. So this is equal to 2 by 3. So from here I'll say velocity of the rain is equal to 10.8 into 3 by 2. So this will become 32, 16. So it will be close to option A. It will be close to option A. I think it is 2 by 3. Otherwise we will see what it is. Once we know that value exactly, we will do it. Two bodies are thrown from the same point with the same velocity of 50 meters if their angles of projection are complementary to each other and the difference of maximum height is 30, the minimum and maximum heights are, okay, they are thrown with a velocity of 50 meters per second. So height is equal to what? 50 into 50 squared into sine squared theta by 2g. This is the thing. So 50 squared is like 2500 by 20. So it is 125 times 125 times 1 is sine squared theta and the other one will become cos squared theta. So that will become 125 tan squared theta. Okay, and if I have to subtract them, it will become 125 into sine squared theta minus cos squared theta. So this will give me the difference in range. So this is equal to 30. So I'll bring the 125 here. So 5 will go 6 times, 5 will go 25 times. So sine squared theta minus cos squared theta is 6 by 25. So from here I can convert the cos squared into 1 minus sine squared. So 2 sine squared theta minus 1 is equal to this much. So I can say 2 sine squared theta is equal to 31 over 25. I'll take this minus 1 to that side. Or sine squared theta is equal to 31 over 50. That is like 62 by 100. So sine theta is 64 by 100. So 8 by 10. So 4 by 5. So 4 by 5. Sine theta is 4 by 5. So if sine theta is 4 by 5, then what will I get? Into 16 by 25. So 80 is one number. So 80 is one number. So I'll go for this one. Okay. A circular disc. Okay. So you might be wondering, what have I done here? What have I done means one height is equal to u squared sine squared theta by 2g. The other height is equal to u squared cos squared theta by 2g. Why? Because the angles are complementary. Complementary means that 91 is theta, the other one will be 90 minus theta. So I substituted, I got sine squared minus cos squared because the difference is given to be 30. So I found out sine squared minus cos squared and then I rearranged and then I got this answer. A circular disc is rotating about its own axis at the rate of 200 revolutions per minute. Two particles are at a distance of 5 from the axis of rotation. The ratio of their angular velocities. Angular velocities are the same, 1:1. It is only the linear velocities which will be different. For a disc, when 2 points are given, every point on the disc has the same angular velocity. Linear velocities only will be different. A particle P is moving in a circle of radius A with a uniform speed V. C is the center of the circle AB. When passing through B, the angular velocity of a particle P is moving in a circle of radius A. This is A. C is the center of the circle and AB is the diameter. Okay, AB is the diameter. About A is how much? A and C are how much? Now we are talking about this point and this point. So now when we are talking about these 2 points, now the angular velocity becomes different. Understand, V is equal to omega r. Okay, so the velocity about this is, the angular velocity about this point is omega. For this point, this is 2 times A. So the angular velocity will be omega r by 2. So from here it will become 2:1. 2:1. For this point, velocity is fixed. Linear velocity is fixed. If linear velocity is fixed, for smaller radius, angle will be more. For example, when you're sitting in a train, now the far away points, they're all moving kind of in a circle. The ones which are small, closer, they appear to be moving faster, and the ones which are far will appear to be moving slower. Same concept comes here. In fact, no other possibility is there, because about A and C, so this is smaller. Oh, that is a problem. About A and C, so A is this far away point, C is the small closer point. So A and C means it should be 1:2, not 2:1. 11 forces each of 5 Newton act on a particle simultaneously. If each force makes an angle 30 degrees with the next one, then the resultant of all the forces. So I'm going to use the parallelogram law, but now there are 12 sides. Okay, so suppose there are 6 sides, 1, 2, 3, 4, 5 and 6. So now there are 1, 2, 3, 4, 5 and 6. Suppose there were only 5 forces. So the resultant would have been this force. Okay, so now 11 forces each equal to 5 Newton, 30 degrees. So it will be equal to same 5 Newton. Same 5 Newton. Okay, I hope you are able to understand. I drew it for 6. You can draw it for 12 and then check. One is missing. According to the parallelogram law, if many forces are acting at a point and if you join them such that one tail is on the head of the other and it forms a closed figure, the resultant of this is 0. If it doesn't form a closed figure, you take the tail and join to the head. That will give you the resultant. So if I take the tail and join it to the head, it will be the 12th side. 12th side will be same because it's a regular polygon, because the angle is 30. 30 into 12 is 160. Body is projected with a certain speed at angles of projection of theta. Whatever is the answer, you just write it there. Okay, a body is projected with a certain speed at angles of projection. One is projected at theta and one is projected at theta minus 90. The maximum height attained by the two cases are, this one is 20 meters, this one is 10 meters. So height attained is equal to u squared sine squared theta by 2g. In the other case, because it will become cos squared theta divided by u squared cos squared theta by 2g. So since everything is the same, I can say h1 by h2 is equal to tan squared theta. So from there you will get that this is 1 by 2. So tan squared theta is equal to 1 by 2. So tan theta is equal to 1 by root 2. So theta should be tan inverse of 1 by root 2. They are asking you what is the maximum possible range. So the range is u squared sine 2 theta by, so this will be the range. So this will become equal to u square is given to us. Oh, u is not given to us. We'll have to find out. Okay, we will find out. So it is given to me that u squared sine squared theta by 2g is equal to 20. U square cos square theta by 2g is equal to 10. So from here I can now find this out. The range is equal to 2 times u sine theta by g into u cos theta by g into g. So this is going to be the range. So from here what I will do is I will take the 2 this side. I will take the 2 this side. Then again I will take the g also this side and I will take square root. So the answer should be square root of 2 into 20 into g into the same thing I will do this side, root of 2 into 10 into g. Okay, this whole thing divided by g. So the g will get cancelled. So the simple, remember, answer is root over of, the shortcut is 2 of h1 into h2. So that will be 2 times root over of 20 into 10, that is 200. So that will become 20 root 2. So 20 root 2. So 20 root 2, root 2 is 1.414. So 28 close to 30 meters. So the range is close to 30 meters. Okay. So the way you do it is, you have a shortcut for these kind of questions, that the range is equal to 2 times root over of h1 into h2. So that will simply be 2 times root over of 20 into 10. So I hope you understand the derivation for it. So from here I will get 2 into 20 root 2. So 20 root 2 will be equal to approximately 30. It is not a good idea to remember this. If you remember this, great, but otherwise I hope you understand how to derive it. A flywheel is rotating about its own axis with an angular velocity of 11. Its angular velocity in revolutions per minute. This is a simple one, 11 radians per second. So 11 radians in 1 minute, it will go into 60 divided by, they want it in revolution. 1 revolution is 2 pi radian. So divided by 2 pi. Pi is 22 upon 7. So the 11 will go 2 times. This will go 15 times. So 15 into 7 is 105. So it is 105 revolutions per minute. An aircraft executes horizontal loop of radius 1 kilometer with a steady speed of 900 kmph. The ratio of centripetal acceleration with acceleration due to gravity. Now this is horizontal loop. So horizontal loop means centripetal force is V squared by R. So when I go for 900 into 5 over 18, 18 will go 50 times. So this is 250. So 250 into 250 divided by radius is 1 kilometer. So 10 power 3. So that will become equal to, this is equal to 625. 625, so 62.5. So 62.5 divided by 10. So that is 6.25. So the ratio is 6.25. 6.4 is also good enough, because if you assume this to be 9.8, it will be approximately 6.4. So I'll go for B. So centripetal acceleration is V squared by R. A ship is moving due east with a velocity of 12 meters per second. A truck is moving across on the ship with a velocity of 4 meters per second. So there is a ship which is moving due east. So there is a ship which is moving due east at 12 meters per second. On the ship there is a truck which is moving across the ship with a velocity 4 meters per second. A monkey is climbing the vertical pole mounted on the truck with a velocity of 3 meters per second. Find the velocity of the monkey. So 3 meters per second, I'll say it is 3 j cap. Then again, I'll say it is 12 I cap plus, or I'll say this one as k cap. So that way it will become easy. Plus 4 j cap. So this is the velocity. When you find this out, it will be square root of 12 square plus 4 square plus 3 square. So that is 13. A boat takes 2 hours to travel 8 kilometers and back in still water. So in still water, it takes 2 hours to travel 8 kilometers. So 4 kilometers per hour is the velocity of the boat. With water velocity of 4 kmph, the time taken for going upstream of 8 kilometers and coming back is how much? So 2 hours means 120 minutes. So now it should take, we'll see how much it is. So 2 hours, 8 kilometers. So 4 hours, velocity of 4 kmph, the time taken to go upstream of 8 kilometers and coming back is how much? Basically, the boat speed is 8 kmph, 4 kmph. The velocity of the water is also 4 kmph. So the net velocity will never come back to its mean position. So there is something wrong in this question. I'll see and get back. A cyclist riding with a speed of 27 kmph. As he approaches a circular turn on the road of radius 80, he applies brakes and reduces his speed. Concentrate. The net acceleration of the cyclist on the circular turn is how much? So it is mv squared by r. So the centripetal force is mv squared by r. So centripetal acceleration is v squared by r. So he is going at 27 kmph. So 27 into 5 by 18. 18, 9 will go 2 times, 9 will go 3 times. So that is 7.5 meters per second. So 7.5 into 7.5. So 7.5 into 7.5 divided by radius is 80 meters divided by 80. So this is the centripetal acceleration. So if I find this out, 75 into 75 is like 5625. So that is 56.25 divided by 80. So this will be the acceleration towards the center, and there is a radial acceleration of 0.5. So the resultant will be, this will be close to 7 times 56. 8 into 7 will be 56. So this will be close to 0.7. So 0.7 and 0.5. So when I find out the resultant of 0.7 and 0.5, it can't be 0.5, it can't be 1, it can't be 0.8. So it has to be only 0.56 meters per second squared. So I hope you are able to understand. I don't even have to do anything. There's a tangential acceleration of 0.5 and then there's a centripetal force. Centripetal force we have found out is like 0.7. So the answer cannot be nor can it be more than 0.7. So these three are eliminated. So only option C is the right one. So let's look at question number 32. a person reaches a point directly opposite on the other bank of a river. So the velocity of the water in the river, so this is a river, so the velocity in the water of the water in the river is 4 meters per second, and the velocity of the person in still water is 5. So the person can travel at 5. Now if the width of the river is 84.6 meters, time taken to cross the river in seconds is how much? So I am assuming time taken to cross the river means it will be to go from this point to the other point, in which case the man will actually swim this way, so that he will swim this way, I mean the water will push him this way, and then ultimately his displacement will be like this. Now this is given to us as 5, this is 4, so this has to be 3. So the time taken will simply be 84.6 divided by 3. So that will be 28.2. So the answer is 28.2. Actually, if you look at the options, none of the other options are possible. So when two bodies approach each other with different speeds, the distance between them decreases by 120 meters for every 1 minute. That means it decreases by 2 meters per second. That means the sum of their velocities is 2 meters per second. So this cannot be the answer, this cannot be the answer, this can be the answer, this cannot be the answer. So option C has to be the right answer. So if two people are moving in opposite directions, the distance between them will reduce by u1 plus u2 per second. When they are going in the same direction, the distance will reduce by u1 minus u2 mod, whichever is great. The square of the resultant of two forces 4 and 3 exceeds the square of the, this should be difference of the two forces by 12. So this is something which is very unlikely. Anyway, we will see. When they are mutually exceeds the square of the resultant of the two forces by 12 when they are mutually perpendicular. Okay, then the angle between the forces is how much? So 4 Newton and 3 Newton are mutually perpendicular, so the resultant is going to be 5. Okay, now initially suppose the angle is theta, then the resultant will be equal to square root of 4 square plus 3 square plus 2 times 4 into 3 into cos theta. Cos theta, so I'll just put it as cos theta. So this minus 5 is equal to 12. So when it goes that side, it will become 17. So it becomes 17. So I'll square both the sides. So 17 into 17 looks like 4 square, that is 16 plus 9. So this is very unlikely because this force is a large number. The square of the resultant of two forces. They are talking about the square of the resultant of the two forces. So square means the square is not be there. So now it's a little feasible. Let us see. So 16 plus 9 plus 4 into 3 is 12 into 2 is 24. 24 cos theta is equal to 17. So from there I can now say that if I take this side, cos theta is negative. Cos theta is negative only for angle greater than 120. Let us see if we are getting it. So 16 and 9 is 25. 8 it becomes. So cos theta becomes equal to 8 divided by 24 negative. Yeah, so that is equal to negative 1 upon 3, which is not the answer. So resultant of two forces A and B is a square plus b square plus 2ab cos theta. The square of this exceeds the, not the difference, exceeds the resultant of the two forces by 12 when they are mutually perpendicular. Yeah, so we can just go for angle 120, but there is some issue here which we need to check. Maybe I'll do it once again. The resultant of two forces 4 and 3 is 4 square plus 3 square plus 2 into 4 into 3. 4 into 3 is 12, 12 into 2 is 24, 24 times cos theta. Exceeds the square of the two forces by 12 when they are mutually perpendicular. So there also it is not just by 5, it is 25. So let us see again. So I'll just do it again. Yeah, so let's look at question number 34. So 4 square plus 3 square plus 24 times cos theta exceeds the square of the resultant of the two forces by 12 when they are mutually minus 25 is equal to 12. So this goes that side. So this is 25. So this gets cancelled. So cos theta is equal to minus 1 by 2, and from there you will get d is this much. Though it is given that this O is at equilibrium, then they are asking you for 20 Newton is acting vertically downward. So this is 20 Newton. So they are asking us to find out T1 and T2. So Let me see first. This angle here, this is 60, this full thing is 150, but this angle here will be 30. So 30, this is 90, and this angle here is also equal to 30 because this full thing is 150. So now once the geometry is clear, now everything will be clear. So suppose this is T2, so T2 times cos 30, T2 times cos 30 is equal to T1 times cos 60 is equal to T1 times cos 60. So from here itself I can get the ratio. Cos 30 is root 3 upon 2, cos 60 is 1 upon 2, 2 gets cancelled. So from here I can say that T2 by T1 is equal to 1 upon root 3. So let me see where that thing is 1 upon root 3. T2 by T1, they have asked me for T1 and T2. So this is not 1 upon root 3. Okay, so this will be the answer. Yeah, T2 into root 3 is equal to T1. So that should be the answer. A boat takes 4 hours to travel certain distance downstream. So let the distance be equal to x. So x divided by u boat plus u stream is equal to 4 hours. And then it takes 6 hours to travel the same distance upstream. So x divided by u boat minus u stream is equal to 6 hours. So in such cases just divide one by the other. So you will get ub plus us divided by ub minus us is equal to 3 upon 2. That is, I am dividing one by the other. Now apply componendo dividendo. So it will become 5 divided by 1. What is this 5 divided by 1? That will be equal to u boat by u stream. So let me see. Then the time taken by the boat to travel the same distance in still water is how much they are asking. Okay, so now this has made it slightly complicated. So we'll have to find out what each one of them is, and then we will do. So let's see, ub plus us is equal to x, or 4 times plus 4 times is equal to x. 6 times ub minus 6 times us is also equal to x. So I'll multiply this by 6, I'll multiply this by 4. So I'll get 24 times ub plus 24 times us is equal to 6 times x. 24 times ub minus 24 times us is equal to 4x. So now if I add them, I'll get ub is equal to 2x divided by 48. Yeah, or ub is equal to x divided by 24. Now what do I need? I need x divided by ub. So x divided by ub will become 24. So that will give me the right answer. Okay. So I hope once you see the equation, then it works out to be correct. If a stone is to hit at a point which is at a distance d away and at a height h above the point stone, then what is the value of the initial speed if the stone is launched at an angle theta? So always I keep telling, in any projectile motion the time of flight is most important. So if it is launched with u, this becomes u cos theta is the horizontal velocity, then u sin theta is the vertical velocity. So the time taken for it will be d divided by u cos. Okay, so because there is no acceleration in this direction. Now if time is equal to d divided by u cos theta, in that same time it is reaching a height h. So I can say that h is equal to u sin theta t. So u sin theta into d divided by u cos theta minus half into g into t square, that is d square divided by u square cos square theta. Okay, so now the question is to find the value for u. So to get the value for u, what do I do? This u gets cancelled, so I don't have to worry about it. So I'll take this side, I'll bring this side. So it is d tan theta. So it looks like d tan theta minus h is equal to, so this will come under square root. So d tan theta minus h and the square root is there in option A or in option B. So then rest of it we'll be able to find out, no problem. So I'll just clean it first. Oh, but that my answer is also gone. Okay, so one of this, either this or this has to be the answer. So if I have to think alternatively, what do I do? Suppose theta was 90 degrees and d was 0. If theta was 90 degrees and d was 0, but that won't work out. Anyway, let me do it again. So it is d divided by u cos theta, this is the time. H is equal to ut d by u cos theta into u sine theta minus half into g into t squared, d squared by u squared cos squared theta. So from here cos theta should come, sine theta won't come, so option D is the right answer. We have already seen this part, then it should be cos theta. Here cos square theta is there, so cos theta should come. So that should be the answer. This we have already done. If a projectile crosses two walls of equal height set symmetrically as shown in the figure, choose the correct statement. So if it is crossing two things, the time of flight is 8 seconds. So the range is 120. So u squared sine 2 theta by g is equal to 120. Then the height of each wall is 60. The maximum height of the projectile is 80. All of the above are true. So let us see what is going to happen, how it is going to happen. Okay, so at t is equal to 2 seconds, it is crossing the first wall, and at t is equal to 6 seconds, it is crossing the next wall. Okay, so no problem. So here if it is u sine theta, vertical velocity, this will be u cos theta. So this velocity at this particular point will be u sine theta minus 20. Yeah. Now I know the time taken to go up is equal to time taken to come down. So if it has reached here in 6 seconds, it would have gone up for 3 and come down for 3. So if it has gone up for 3 and come down for 3, that means here the vertical velocity would be 30 meters per second. Yeah. That means this is equal to 30 meters per second. That means u sine theta is equal to 50 meters per second. Okay, so 50 meters per second. Now we can find out totally what is the total matter. So the total time of flight is 8 seconds is obviously wrong, because it takes 2 seconds to go here. Oh, okay, correct. The statement is correct. Understand, it takes 2 seconds to go here. I made a mistake. I said this total time is 6 seconds. No, that total time is only 4 seconds. Okay, let's do question number 38. If a projectile crosses two walls, it is given that this is 120, this is 2. So let this vertical velocity be equal to u sine theta. At this particular point, the velocity will be u sine theta minus 20. Why? Because this is 2 seconds. So here it is 6 seconds, means from here to here it is 4 seconds. That means here the velocity, it takes 2 seconds to go up and 2 seconds to come down. So here it is 20 meters per second. That means here also it would be 20. So this is equal to 20, meaning u sine theta is equal to 40 meters per second. So if it is 40 meters per second, then it going up is 4 seconds, coming down is 4 seconds. So this is correct. The height of each wall is 60 meters. We will see the maximum height of the projectile. So that is easy for us to calculate. The maximum height is u squared sine squared theta by 2g. So that is 40 into 40 divided by 2 into 10. 0 0 cancels, so this is 80. So A is correct, C is correct. So all have to be correct, all the above must be correct. An object is projected up the inclined plane at an angle shown in the figure with an initial velocity of 30. The distance x up the incline at which the object lands is how much? See, these kind of questions will never come in the JEE and the NEET, but they can come in the JEE. In fact, it was there in the JEE papers. So if this is, so what I am going to do first is, this is the inclined plane. I'm just going to make it horizontal. So if I make it horizontal, it has gone this way. Only thing is, when it is going up, now when it is going up, this acceleration is g sine theta. Okay, and in the vertical direction, its acceleration will be g cos theta. So in a regular projectile, there was only horizontal, there was no acceleration, there was only vertical acceleration. But in this case, there will be both horizontal and vertical. So here, this acceleration is g sine theta. This is how the particle is going, and this acceleration is g cos theta. Okay, now everything else is the same. So the particle is projected at 30 meters per second at an angle of 30. So the time of flight, always time of flight is the most important thing. Okay, so the time of flight is going to be equal to 30 times. I can break it up into cos 30 and sin 30. Sin 30 is 1 by 2 into 1 by 2 divided by the vertical acceleration is g cos theta. G is 10, cos theta is cos of 30 is root 3 by 2. So this 2 gets cancelled, 10 gets cancelled. So the time of flight is root 3 seconds. So root 3 seconds to go up, another root 3 seconds to come down. So 2 root 3 seconds. So during this time, what will be the horizontal distance travelled? So this I know, S is equal to ut. U is 30 into root 3 by 2 into 2 into root 3 ut minus half into 10 into cos theta. Cos 30 is root 3 by 2 into t squared, root 3 into root 3. So S is equal to ut minus half gt squared. So this should give me the answer. So the 2 gets cancelled. So this is 3. So S is equal to 90 minus. So let's discuss question number 40. A bullet is fired with a speed of 1500 meters per second in order to hit a target 100 meters away. So there is a target here 100 meters away and the bullet is fired at this, and it is fired at 1500 meters per second, and this is 100 meters. Now obviously if he fires straight, because of gravity the bullet would move somewhere here and hit here. So what should he do? He should fire it this way such that because of gravity when it comes down it will hit the target. So what do we do? So for any projectile motion, remember the time of flight is the most important thing. So time of flight here will be 100 divided by 1500 seconds. So these two will get cancelled. So it will be 1 by 15 seconds. Now in 1 by 15 seconds, what would be the drop because of gravity? S is equal to half into 10 into t squared. 1 by 15 into 1 by 15. So 2 will go 5 here, 5 will go 3 times. So S is equal to 1 by 45. So he should target at a point which is 1 by 45 meters above. 1 by 45 meters means what? 100 by 45 centimeters. So that will work out to be 2.2 centimeters. Okay, so he should hit the target 2.2 centimeters above. So there is a motorboat going downstream. So there is a motorboat which is going downstream. When it is going downstream, its velocity will be the boat velocity plus the stream velocity. At some instant he crosses a plank and then he goes this way for 1 hour. Remember, as he is going, the plank also moves. So after 1 hour, the distance between them will be equal to u-boat. Do you understand? The velocity of the boat will be u-boat plus u-stream because he is going downstream, and the plank will also be moving with the velocity of stream. So after 1 hour the distance travelled will be equal to u-boat. Later it turns back and after some time it passes the floating body at a distance of 12 kilometers again. So now when this person reaches here, this plank has moved a distance which is equal to u-stream, such that this distance is u-boat. Now he is travelling this way and the plank is also travelling this way, but his velocity is u-boat minus u-stream. So together the plank and the motorboat will cover a distance of u-boat per second. Yeah. So now he has to travel this distance of ub. So again he will take 1 hour. So that means he travelled for 1 hour and he returned back for 1 hour. So in 2 hours the plank has travelled a distance of 12 kilometers, because the next time he has crossed it at a distance 12 kilometers from the starting point. So in 2 hours the plank has travelled 12 kilometers. So the velocity of the boat, velocity of the stream will be 6 kilometers per hour. I hope you are able to understand. What I am saying is, suppose he crossed the plank here. Now the total distance travelled is u-boat plus u-stream. 60 minutes is 1 hour. Now in the same time the plank travels a distance of u-boat. Now when he is returning, his velocity is u-boat minus u-stream. Now the plank is travelling at u-stream. So the relative velocity is again u-boat. They both will meet if the total distance travelled is u-boat. So that is 1 hour. That means the plank from the starting has been moving for 2 hours. So in 2 hours it has moved a distance of 12 kilometers, so it is 6 kilometers per hour. A hiker stands on the edge of a cliff. So there is a cliff here and 490 meters above the ground, and throws a stone horizontally with an initial speed of 15. So the stone will go and hit here. The time taken by the stone to reach the ground, S is equal to half gt squared. So 490 is equal to half into 9.8 into t squared. So this will become 4.9, it will become 100 here. So this will become 4.9 t squared. 4.9 will get cancelled here and it will become 100. So t is equal to 10 seconds. So the answer will be 10 seconds. Neglecting air resistance, the time taken by the stone to reach the ground in seconds will be how much? So it should be close to 10 seconds. So of these answers, this is the closest to 10 seconds. So I will take that. Which of the following sets of forces acting simultaneously on a particle keep it in equilibrium? So only that one which can form a triangle can keep it in equilibrium. To form a triangle, sum of two sides should be greater than the third. So this plus this is not greater than this, not possible. Now here sum of two sides seems to be greater than the third, this is possible. Here not possible, here also not possible. So this is the only option. So this is the only situation where sum of two sides is greater than the third side. A swimmer is capable of swimming 1.65 meters per second in still water if she swims directly across a 180 meter wide river. So there is a wide river whose current is 0.85 meters per second. How far downstream from the point opposite her starting point will she reach? So she is trying to go this way, 1.65 meters per second. Now this distance is how much? 180 meters. Now the stream is flowing at 0.85. So obviously if this is 185, this distance traveled would be close to 90. So which of the options is close to 90? Only option A is close to 90. So I don't have to really do it. I can, by inspection, I can say this velocity is almost little more than half of this velocity. So the distance traveled will be little more than half. So half of 180 is 90, little more than 90 is 92.7. Two light strings each of length 4 and 3 are tied to a bob of weight 500 grams. The free end of the strings are tied to pegs in the same horizontal line separated by 5 centimeters. So this is 5 centimeters, this is 3, this is 4, and there is a bob here. The ratio of the tensions in the longer string to that in the shorter string is how much? So this is 5, this is 4, this is 3. So this is a perfect right angle triangle. So this angle is 90 degrees. So what can I do? I can resolve the forces. If this angle here is theta, this angle here will be 90 minus theta. So suppose this is T1, this is T2. So I can say that T1 cos 90 minus theta, that is sin theta, will be equal to T2 cos theta. T2 cos theta. Okay. So from here I can say that they are asking me the ratio of the tension in the longer to that in the shorter. So T2 by T1 is equal to sin theta by cos theta. Okay. So now if this angle is theta, this angle is also theta. So sin theta is 3 upon 5, cos theta is 4 upon 5. So the answer is 3 upon 4. Sorry, it's a 45th question. So 3:4. This will be the answer. Sorry. Two bodies are thrown with the same initial velocity at angles theta 90 minus theta respectively with the horizontal. Then their maximum heights are in the ratio. This is not the answer. Maximum height, what is the formula for maximum height? H is equal to u square sine squared theta by 2g. So one is sine squared theta, one is sine squared 90 minus theta. So the answer has to be option C. Sine squared theta is to cos squared theta. A swimmer is capable of swimming. This we have already worked out. How far downstream will she reach? Already we have worked out. This question is repeated. A ball is projected from a point A with a velocity 10 meters per second perpendicular to the inclined plane as shown in the figure. Range of the ball on the inclined plane is how much? So there is an inclined plane, perpendicular to that a ball is projected. So perpendicular to that the ball is projected. Like any projectile motion, time of flight is the most important thing. So whenever we talk about these inclined planes, just treat it like a normal straight plane. Only thing is, in this direction the acceleration is g sine 30. In this direction the acceleration is g cos 30. Okay. So now the ball is projected at 10 meters per second. So the time of flight will be 2 times 10 into g cos 30. Now cos 30 is how much? Root 3 by 2. So 2 here. So the 10 will get cancelled. So it is 4 by root 3. This is the time of flight. Okay. Now for this much time, the body is also moving in the horizontal direction. So I can say S is equal to half a t squared. So half into 10 into sine 30. Sine 30 is 1 by 2 into t squared. T squared is 4 into 4 by 3. So now when I simplify this, 4 gets cancelled. So 40 by 3. So 40 by 3 is option A. So this is the answer. Okay. Now inclined plane. In an inclined plane, this is G. So this is G sine theta and this is G cos theta. All questions will be worked out by this. A circular plate is rotating about its own axis at an angular velocity of 100 revolutions per minute. The linear velocity of a particle P on the plate at a distance 4.2. So V is equal to omega R. Omega is 100 by 60 into R is 4.2 by 100. So many meters per second. So I can cancel these two. 6 will go 7 times. Okay. So 4.2. So this will become 10. This will be 6 will go 7 times. So 0.07. So the answer is 0.07 meters per second. Okay, there is an error here. I have not taken 2 pi. So it is 2 pi into 100 divided by 60 into 4.2 over 100. So it will be 0.7 into 2 into 22 by 7. So this will give you 44.44. So 4.4 meters per second. So this is going to be the answer. 0.7 into, let me check whether it is just 0.7. These two gets cancelled. So this will go 0.6 will go 0.07. So it is 0.07 into this much. So this will be 0.44 meters per second. Not D. Option B is the right answer. If ABCD is a quadrilateral whose sides represent vectors in cyclic order, AB is equivalent to parallel. The polygon law of vectors say that this is suppose A, B, C, D and then there is E. The sum of all these vectors is 0. So AB vector will be equal to the negative of all these or the sum of all the other vectors. So BC, CD, DA, but the negative of this. So AD, DC and BC. So option C is the right one. So now there is one particular questions which I have avoided. So the questions which I have avoided are a few questions related to inclined plane projectiles. Okay, so let me explain this inclined plane projectile to you all over again. Suppose this is an inclined plane. If this angle here is theta and if there is a particle here which is projected perpendicular to this, so this angle here is 90 degrees. So what I am going to do is that I will understand that if this is G, this G can be resolved into two components, G sine theta and G cos theta. Okay, let us not have this condition that it is perpendicular. Let's say that this angle here is some alpha. So if that angle here is alpha, then how do we go ahead with it? So the way we go ahead with it is first understand that if this angle is alpha, so I'll straighten it. So once I have straightened it, this angle here is alpha. So if this angle here is alpha, again that perpendicular velocity will be u sine alpha. Horizontal velocity will be u cos alpha. In the horizontal direction there is an acceleration g sine theta. In the vertical direction there is a negative acceleration g cos theta. Always time of flight is the first thing. So time of flight will become equal to 2 times u sine alpha divided by g cos theta. Okay, so this I hope all of you understand. Time taken to go up is always equal to the time taken to come down. So 2 times u sine alpha by g cos theta is the time of flight. Now in this much time, what is the horizontal distance travelled? So S is equal to horizontal velocity is u cos alpha, t is 2 times u sine alpha divided by g cos theta plus half into a is g sine theta into t squared. T squared will become again 4 times u square sine squared alpha divided by g squared cos squared theta. So this is going to be the time taken. So now I am going to sort it out and make it look a little better. So I can say that S is equal to the 2u square by g cos theta into cos alpha sin alpha. So I can remove this 2 and say that sin 2 alpha plus half into, so one g and this g gets cancelled. So this 2 here and this 2 here will get cancelled. So I can say that this half won't come. So instead of half it will be 2 times u square sine squared alpha divided by g cos squared theta. Okay, so now if this is the situation, I can do some regrouping here, or I can just say this, I will just remember this, S is equal to u squared sine 2 alpha divided by g cos theta plus 2 times u square sine squared alpha divided by g times cos squared theta. There is one term missing, the sine theta is missing in the numerator, so there will be a sine theta here. Okay, so this is equal to S. Yeah, this is equal to S when you have projected it at an angle and it is going from top to bottom. Now if you are pushing it from bottom to the top, this is not an acceleration, this is going to be a deceleration, in which case it will be ut minus half gt squared. So there will be a negative sign in between when you push a projectile from here up. Okay, now these kind of questions are very unlikely to come in the NEET exam. In the JEE exam there was a question of this kind even 2 years back. So those of you who are preparing for JEE definitely should learn this concept. It is very difficult to memorize these formulas, so don't try to memorize this, just try to learn it. Okay, so all that I am saying is you just tilt the inclined plane. Now in a regular projectile there is acceleration only this way there is no acceleration. In an inclined plane projectile, in this direction there is an acceleration, in this direction there is a deceleration. When you are throwing it up, there is deceleration on both the sides. So that is all that you need to work. So now quickly let's look at the questions that we have missed.